If you watched my video on probability and permutations and combinations, you would know that it was a little bit rough. Probability, not my thing. And what's even less of my thing is statistics. To be entirely honest, I have never once taken a statistics class in my life. I had to take I had to answer some questions about statistics in order to get my teaching credential in math. I'm not entirely sure how that happened, honestly. When I went and took my test, the statistics questions killed me. Those were the worst. I passed, so apparently I know it well enough to teach it, which, I mean, I don't know anything about statistics, so I don't know what that tells you about teacher certification in California, but anyway, 0-8, statistics. I'm going to tell you as much as I know, which is essentially just sort of explaining what some of these words and symbols mean and how you're going to calculate some of these various measures of middleness and spread and things like that they're going to be asking you to do. And then I'm going to show you how to do it all in Desmos without even thinking or calculating anything, and it's going to be amazing. I went to school for engineering. I don't really have a joy or a love for the math portion of this. I just want answers. So I'm going to help you just find answers. But again, we do have to go over like how you find these things because it is good for you to know at some point, I guess. I don't know. I've never needed it. Statistics was always like this lame social science math that other people who didn't really know how to do math would have to take. But anyway, let's go through this. So statistics, really what we're doing with statistics is we're collecting, analyzing, interpreting, presenting data in various ways. And what we're talking about specifically is descriptive statistics with one variable, or univariate data. That means there's just one variable. You're not dealing with multiple factors. So we have a few different measures of middleness, measures of central tendency. And we can look at different sets of people as we do that. So the first one is the population. You can find a population mean or a sample mean. The population is just everybody. The sample mean is just like your small group of people that you might be looking at, or the small set of numbers that you're looking at from the greater population. So that's really all that is. So the mean here, the population mean, also represented by the Greek letter mu, is equal to, well, that's another Greek letter, sigma. It means the summation of x, which are all of your data points. So you add up all of your data points, and then n is the number of data points. You're just finding an average. You just add all the numbers up, divide by the number of numbers. That is your mean. And whether it's your population or your sample doesn't really matter all that much, except in the Greek letters that we use. So mu for the population, and we call this x bar because there's an X with a bar on top. I guess mathematicians aren't very creative with names, honestly. So that's easy. Median, the middle, it's like the median on the freeway, is literally just the middle number. So if you take a data set like this down here and write it out from the smallest number to the biggest number, let's say it was already smallest to biggest, you would literally just go through and cross off one on each side until you get down to some middle number. But in this case, it's not written out that way, so I wouldn't do that to find the median. And then the mode is just the most common number. So if you have 5 4s and everything else has lower than that, then 4 is your mode. It's just the most common. It's very easy to do. So looking at this data set, this is what I mean by the mean. You literally just add all the numbers up, and apparently there's 12 numbers, so you divide by 12 and you get 9.08. So that is your mean. The median is the middle number, but in this set of data, we actually have 12 numbers, which is an even number. So you can cross off, 5 on each side, and you get down to your middle 2 numbers. If you ever have a situation like this, instead of one middle number, you just take the average of the 2 middle numbers. So you get 8.5. And then mode, again, the most common value. And 4 shows up 1, 2 times, and nothing else shows up more than once. So those are all measures of central tendency. These are all different ways that we can talk about like the average person. normally when we talk about like an average home value or an average person, we're not actually talking about an average, because for example, dealing with home values, you have what's known as outliers. You might have a bunch of pretty normal homes in your city, but up on the hills, you're going to have some mansions that are worth tons and tons of money, and those will throw your average way off, and your average will look actually like higher than what you would say the typical person pays for their house. And that's why we deal with median. Medians are really nice in eliminating some of those outliers. It gets rid of the really big values and the small values, and we do end up with a good middle number. And then mode is just the most common, which is actually really useful when you're dealing with information that is not numerical. So like, what's your favorite sport, for example? The most common answer for that would just be your mode, but you can use it for numbers too. So those are all measures of central tendency to talk about sort of like the average person. Now the next thing that we're going to talk about are called measures of spread or variation. So measures of spread are a way of determining like how far spread out are your values. If you have values that are spread just kind of all over the place, your measure of spread is going to tell you that, and that's going to say, while we could say that there's an average value to this, it doesn't mean as much because the data points are so far spread out. But if they're all clustered pretty close together, and that shows up in your measure of spread, then, which actually I completely forget what even numbers would tell you whether it's spread out or not. We'll get to that in a minute, apparently. Anyway, if you find out that your numbers are pretty closely grouped together, then you know there's less variation to those numbers, and you can sort of more confidently say things about the group as a whole based off of averages or mean and stuff like that. So a couple of these measures of spread. The first one is range. That's literally just the biggest number minus the smallest number, and that just tells you how far apart the biggest and smallest numbers are. Now, variance, and I think that's a delta squared, or just s squared. Your variance is equal to the sum of the deviations from the mean, and deviation just means how far off of the mean are we. So you literally take each of your data points and then you subtract the mean from that, and then you take all of those numbers and add them all up. So up here our mean was 9.08, so we would take 14 minus 9.08 plus 7 minus 9.08 plus 12 minus 9.08. But you'd actually have to square all of those. So you do 14 minus 9.08 squared plus 7 minus 9.08 squared plus 12 minus 9.08 squared, and so on and so forth until you get all of them done, and then you divide by the number of numbers that there were, in this case being 12, and that gives you your variance. And then your standard deviation is the average amount by which individual items deviate from the mean of all the data, which I am literally just reading off of here because I didn't know that off the top of my head, is just the square root of the variance, or just delta. So delta squared is variance, delta is your standard deviation. And again, both of those will tell you sort of how spread out your information is. So if we take a look at this, the measures of spread for the entire class, first of all, we would do range. So the maximum number is 10 minus 2. The smallest number gives us a range of 8. So we know our biggest and smallest are 8 away from each other. The mean of the data, we literally add up all of the numbers, all of these, and then divide by 25 because we have 25 numbers in our data set. And then we use the unrounded mean, 7.44, to find the variance. So we would take 7 minus 7.44 squared plus 8 minus 7.44 squared plus 9 minus 7.44 squared, and so on. You do that with all of them, and then divide by n to find your variance, which comes out to be 4.566664, or about 4.6. And then you take the square root of that to find the standard deviation. And I think the standard deviation, the bigger the standard deviation is, well, basically the standard deviation is, it's like an average of how far off your numbers are from the mean. So on average, your numbers are about 2.1 off of the actual average. And so 2.1, that one right there compared to this one over here, well, this one over here has a larger spread. So our averages and medians would be less certain with this group just because we have a higher standard deviation. Our numbers tend to be further off of the average than with this group. So this group would have a tighter group of points than this one. And then there's some really interesting stuff about standard deviations and percentages of data points in your population. I forget exactly what it is, but I think within one standard deviation on either side is something like 20 or 30. I don't know. Look it up. There's a chart for it online. I don't have it memorized. I never took statistics. I'll stick with that. Again, whole bunch of information. Find the mean, the range, standard deviation, the median, blah, blah, blah. Relative frequencies. Okay, well, let's just talk about this for a second. This one's kind of interesting, I guess. I don't know. I've never used this for anything. As far as I know, it's useless. So what you do is it's kind of like a histogram where you just have these groups of numbers and everything falls within one of those. So winning score of 10 to 19, well, we have 5 of them, which is 5 out of 42 of the total, or about 12%. So 12% fall into this category. 38% then, well, this is going to be adding, no, it's not actually, it's not adding up. All these numbers are adding up to 100. Anyway, so in this next group is about 38%, and then the next group is about 36%, and then 10, and then 0.05, so about 5%. It's interesting, I guess. I don't know. Histograms, it's the same thing. It's basically a bar chart of a relative frequency. Cumulative frequency, this one is kind of helpful because let's say you want to know like how many winning scores were under 29 points. Well, this is your cumulative relative frequency. What we're doing is we're adding this group to get my cumulative frequency, and then divide that by 42 and we get our percentage. So it's good to know that 50% of them were 29 or less, and here we've got 86% that are 39 or less, and so on. And 1 is 100%. Don't forget that. Oh, quartiles. Yep. Okay, so we already talked about the median. The median is just the middle number, or the average of the two middle numbers. Your quartiles are Q1 and Q3 because the median is Q2. Now, the reason why they're called quartiles is because they actually divide your data set into quarters. So Q1 marks the point where below that you have 25% of your responses, and above that you have 75%. So between nothing and Q1 is 25. This is 25 between Q1 and your median. This is 25 and this is 25. So if you're thinking in terms of your median, well, 50% of your numbers are below that, 50% are above. If you're looking at Q3, 75% of your numbers are below that, 25% are above. And you just find Q1 and Q3 the same way that you find the median. It's just that you're only looking at the top half of your data set or the bottom half of your data set. And this is where the 5-number summary comes from. We have a minimum value, a maximum value, Q1, Q3, and median. If we look at this, the longer these are, the more likely we have outliers, because this is where like half of our data set lives, right in the middle here. And the further this is spread out, that means that we have some numbers that are way off the median, which is really big. Not super interesting stuff. And then you've got your homework. Now, let me show you the easy way to do all this. I actually already took the data from that first one that we looked at, this one right here, and I input it into Desmos, into a table, just into the X1 chart. So let me swap over there. Yep, all right, so here's my data set. Same numbers and everything. Now on Desmos, we have some actually really nice tools that we can use. Min of X sub 1 is just saying, what's the minimum number in my X1 column? And it's 2. What's my maximum? 20. What's my mean or average? 9.08. What's my median? 8.5. Now, this is where it gets a little bit trickier. So quartile, parentheses, X sub 1, comma, p. Now the p is the number that tells us which quartile we're going to look for. So I'm going to change this to 1. I'm looking for my first quartile. Oop. Whoa. Whoa. I'm just gonna pretend like that didn't happen. Here we go. Cool. First quartile. 4. Q3. Oh no, but yeah, Q3. Quartile 3 would be where Q is 3, and it's 13.5. Okay, good. Mad, that's something from Math 1, which, again, statistics is not my thing. I don't even remember what it was. It was like mean. I don't even know. I don't know. Variance, var of x1, 32.99 or 33. Standard deviation, 5.7. Now, apart from comparing to other sets of data, I don't really know if 5.7, I don't really know what that means. All I know is that on average, our numbers are about 5.7 off of the average value. Now, if we compare to another data set that had a standard deviation of like 3, then we would say that this set has a wider spread. The numbers are not as close to being in the middle. They're not as tightly grouped. So those are some generalizations that you can make. Now, that should be about it. If any questions come up on this statistics section, please let me know.